Okay, good evening. This is Professor David J. DelosReyes. I'm here in Los Angeles, USA. It's September 8, 2023. The time is 10:28 p.m. Okay, my discussion for this session will be college algebra, and this will now be lesson number 56. Okay, let's proceed. This is a long video format discussion, and the topic is college algebra, lesson number 56. The title of the topic will still be Binomial Theorem Part 2. Lesson number 55 is a binomial theorem that will be Part 1. Part 1, because the solution of that binomial theorem is by using Pascal's triangle. For tonight, we will be expanding a binomial term by using the so-called factorial notation. Okay, factorial notation. Then later on, we'll try to bring out a problem, and we will be presenting two solutions, Pascal's and the factorial notation, and let us see if the result will be the same. Okay, let's proceed. To expand a binomial expansion of the quantity, a plus b raised to n equal to, okay, we have done this one already by using Pascal's triangle, and for tonight we will be presenting the expansion of this by using factorial notation. But what is factorial notation? Factorial notation is something like this. If we got a small letter n with an exclamation mark over here, that is termed to as factorial. Okay? N with an exclamation mark is termed to as factorial. If we try to expand this one under the study of algebra, it will be something like this. We will start with n times the quantity n minus 1 times n minus 2, okay, 4, 3, 2. The last value will be 1. Okay? The first value is n. That's the meaning of this. An example of this, if we try to compute for what will be pi factorial by using this representation here, it's just an easy matter. N is actually 5, right? So we'll start with 5. 5 minus 1 will be 4. Okay? Then it will become 3. We will decrease the value of n by 1 till we reach 1 as the last number. This is multiplied by 2, multiplied by 1, and this should be equal to, what will be the value of this one? 20 times 6, this should be 120. So at least we now know how to compute for the value of a factorial thing. If we say 5 factorial, the value will be 120. And to verify the validity of this, actually factorial notation is in our scientific calculator. Okay? It is here. Voila. Okay, it's here. If I will try to take the value of 5 factorial by using calculator without using this formula, we will just display 5. Factorial notation is actually on the second function beneath 3. Okay, second function 3. The value is 120. Okay, that's 5 factorial. But the longhand computation of the 5 factorial is actually 5 times 4 times 3 times 2 times 1 by following this equation here, and the value will be 120. The calculator just display 5, okay, then push the button that shows the factorial notation. It will come out to be 120. Okay? So at least we now know what is the factorial notation. I will place it here. this has not been proven that a 0 factorial is actually 1. We will just accept it for the meantime that 0 factorial is 1, because if we try to use our calculator, later on we'll bring this out on this short video form. Okay, 0, the factorial of 0 factorial is actually 1. The value is 1. Okay, you got it? So from now on, under the study of college algebra, if we say 0 factorial, this should be 1. Because there come a time that we will be using the value of 0 factorial to be equal to 1. Okay, let's proceed with the expansion of the given binomial expression a plus b raised to n. The expansion of a plus b raised to n by using factorial notation, it should be open quantity, closed quantity, n 0 of e to the n plus open quantity, closed quantity, n 1 a raised to n minus 1 b to the first power. If this is 1, the exponent of the first term should be decreased by 1, and the exponent of the second term should be 1. Plus, the next coefficient will be open quantity, closed quantity, n 2, right, times e raised to, if this is 2, the decrease in the value of exponent of a will be n minus 2. So if this is 2, this corresponds to 2. And the exponent of the second term will be b squared. So this is 2, this is minus 2, this is 2. Then the second to the last, it will be open quantity, closed quantity, n in r, a raised to n minus r, b raised to r. If this is r, this should be minus r, and this is r. And the last term should be open quantity, closed quantity, 0 to n, of just simply b raised to n. Oh, that's the formula on how to take the binomial expansion using factorial notation. Is it complicated? It is something like this. I will show you how. We represent this one as K1 maybe. This one. This will be K2. And this will be K3. Okay? This K1, K2, and K3 corresponds to the coefficient on the Pascal's triangle. Right? So this K1 here might refer to this, and this K2 here might refer to this, and this K3 here might refer to this, if the value of n is equal to 3. That's the meaning of this. The problem is, how do we compute the open quantity, closed quantity, and r? Okay? There is a formula on how to compute for that one. The formula will be open quantity, closed quantity, and r. It should be, it's hard to, this is my first time to see a subscript in front. So I will try to read this. If we try to expand this one, it should be a subscript n in front, capital letter C, a subscript r on the far end, right? Okay, and this should be equal to, okay, n factorial over r factorial times the quantity n minus r factorial. So, this is the formula on how to compute for K1, K2, and K3, and so on. This is the formula. So, memorize this by heart. The coefficient of the individual expansion could be computed by using this formula here. That is n factorial all over r factorial times the quantity n minus r factorial. Okay, so you must have to memorize this one. When we go to the example problem, we will be using this one. So for the meantime, we could not visualize the importance of this one, but as we go to the problem, we could visualize the importance of this. Because this formula will give us the coefficients 1, 3, 3, 1 if n is equal to 3. Okay? So the individual coefficients are actually different, right? Like for n is equal to 3, the first one should be 1, this should be 3, this should be 3, then the last one will be 1 because there are only 4 expansion terms. For n is equal to 3, that's the meaning of this. Okay, for the arc term. For the arc term, we will not be using it tonight, but I will be giving it the arc term in an expansion, on a binomial expansion. Supposing you are given a plus b raised to 1,000, and the problem is asking what will be the 500 term, 500, or this 501 term. Could you do it? It's hard to solve that one, because to solve that one, you must have to expand it first. But there is a technique on how to reduce the hardness of the problem. It will be by using the so-called arc term. So for a binomial expansion, the arc term is actually given by this formula here. It will be open quantity, closed quantity, and this is r minus 1. This is a raised to n minus r minus 1, b raised to r minus 1. But try to memorize this one. Okay? And in the computation of this, open quantity, closed quantity, n and r minus 1 is actually a constant. Okay? And what is this constant? The formula on how to take this constant is by following this. Okay? The importance of this. Okay, let's try to bring out a problem. Okay, just a simple one. So we could visualize the importance of the two solutions. Okay? Example, expand using factorial notation. We are given the expression 4u minus 2v raised to the third power. Okay? So if we try to expand this one, we could expand this one by using the long-hand solution. But supposing this is 300, could we expand it? We'll count so many hours or days to bring out that one. That's why we are studying mathematics or algebra, to simplify our computation. So the expansion of 4u minus 2v to the third power. Okay, I will present first solution number 1 by using Pascal's triangle. Okay? This was the topic the last time around. I will bring out first this one, so we will be having an answer. Then later on, we will be expanding this one by using the factorial notation, and let's try to compare the two answers if they are the same. By using Pascal's triangle first, okay? This was the topic the last time around. If we try to compute for the coefficient of the expansion, because the expansion of this, there should be 4 terms, right? It should be n plus 1, okay? So if we try to construct the Pascal's triangle, we got a mistake the last time around on how to draw the Pascal's triangle. This should be the correct one. This should be the correct one. This is 1, right? Then next one will be 1 and 1. Then this 1, right? 1 and 1 will be 2. Then this one again. This will be 1. The middle terms will be 1 plus 2. This will be 3. 2 plus 1 will be 3. Then 1 again. So actually for n is equal to 3, our n here is equal to 3, right? So for n here equal to 3, meaning if we try to expand this, there will be 4 terms. And the coefficient of the first term will be 1. The coefficient of the second term will be 3. The coefficient of the third term will be 3. And the coefficient of the last part will be 1. Okay, let's expand. We'll try to rewrite this one. From our original a plus b, we will let a equal to 4u, what is given. And b is actually negative 2b because this is negative. The operation here is plus. So b here should be negative 2b. So if I will try to rewrite this one, this should be 4 plus open quantity negative 2b, close bracket to the third power. The operation is plus. This is a and this is b. A is 4u, b is negative 2b. Okay, let's try to bring out the expansion. The coefficient of the first one will be 1. This is 1. Right? This is 1. Right? It should be the first term raised to the third power times the second term, negative 2b, raised to 0 power. This should be 3 plus 0 is 3. So in each term, the power of the first term and second term should be always be equal to 3, right? Plus, the coefficient of the second term is 3, right? So this is 3. I will try to write in red so you can see the coefficient. This is 3 multiplied by for you. We finished 3 already, right? So it will be for you. The exponent of the first term is actually decreasing in each term by 1. So this is 3 minus 1. So this will now be 2 multiplied by the second term is negative 2b. It came from 0, so this should now be 1. So if we try to check if it's correct, 2 plus 1 is still 3. Okay? The coefficient of the third one, it's 3, right? So this is 3. Right? For the first term, it should be for you, right? We came from 2 already. So 2 minus 1, this should now be 1. Okay, because it's decreasing. And the exponent of the second term is actually increasing. This is 1, okay? So this should be negative 2b. This is to the second power. It starts with 0, it goes to 1, it goes to 2. The last term. The exponent of the last term is 1, right? So this is 1. Right? And the first term should be for you, okay? This is 1. 1 minus 1 will now be 0. So this is 0. And the exponent of the second term should be 3. Because 0 plus 3 will still be 3. So we are correct. Then try to simplify. The important thing here is that the coefficients should be correct by following Pascal's triangle, right? Then later on, just apply your knowledge on how to expand the first and second term. In every term, the sum of the powers of the first and second term is always equal to n. And here, this is 3 plus 0, it's 3. This is 2 and 1, this is 3. This is 1 and 2, this is 3. This is 0 and 3, this is 3. So it's correct. Then try to simplify. Okay? The first one, this negative 2b raised to 0 power, this should be 1. So 1 times 4u to the third power times 1, it will be 4u to the third power. Right? Let's try to check the coefficient of the second term. We don't try to square first. We try to multiply this 3 times negative 2. That will be negative 6, right? But if we try to square 4, it will still be plus. This is minus. So the sign of the second term will be negative. This is now minus. I put the sign now minus. Right? Because this is negative. It's now negative. 6b. Right? Plus the square of 4u. The square of this. Next one. If we try to square negative 2 here, it will become plus 4, right? So the overall sign of the third term will be plus. Okay? 2 square is 4 times 3 will be 12. So this is 12 times u times the square of negative 2b square. Right? That's correct. The last one. For u to the first power, any number raised to 0 power, this will be 1. So the resulting coefficient of the last part will be 1 times 1. Okay, but if we try to expand this negative 2 to the third power, it's an odd number, so it will be negative. So the sign of the last part will be negative. Negative. Okay, this should be negative. Then expanding. Okay, so meaning to say, we take first the coefficient, we then expand it. On the next operation, we'll try to expand the terms that are to be expanded. So 4u to the third power, 4 to the third power will be 64, and u to the third power will be u cubed. So 4u to the third power is actually 64u cubed. Right? 4 square is 16. times 6 will be 96. It should be negative. We square u, so that's u square times b. This times b. Right? Next one. If we try to square negative 2 over here, it will be plus 4, right? So the sign of the third term will be plus. So 4 times 12, that will be 48, times u, times the square of b, times the square of b. And the last part, a negative 2b to the third power. A negative 2 multiplied by itself 3 times, that will be negative 8, so this should be minus. And b to the third power is actually 8b cubed. So the expansion of the given binomial expression, 4u minus 2b to the third power, there are 4 terms, right? It should be 64u cubed minus 96u square b plus 48ub square minus 8b cubed. If we try to check it, the total exponent of the first term is 3. 3 plus 0 is 3, right? Second term, it will be 2 plus 1, it's 3 also. Second term, it will be 1 plus 2, it's 3 also. And the last part, it is 3 plus 0. So it's correct. So this is the final answer for the expansion of 4u minus 2b to the third power by using Pascal's triangle. Okay, let's try to bring out the solution by using factorial notation, the one we are discussing tonight. Okay? So by using factorial notation, am I still on camera? I will rewrite the given expression, 4u plus open quantity negative 2b raised to the third power. Okay? The first term is just the cube of the first term. Right? The second term, it will be this one, by following this. Open quantity, closed quantity, 3, 1, u square, and b to the first power. Right? Next one will be 3 and 2. We are done with 3 in 1, so this should now be 3 and 2. 4u, 2 minus 1, this will now be 1. Negative 2b, 1 plus 2, this will now be 2. And the last part, is 3 and 3. For you, this is 1 already, so 1 minus 1, this will be 0. Okay? And the second term will be negative 2b to the third power. Right? But this is actually 1. Because if we try to expand this one, the first term is this one, 64u cubed. Okay, we'll do with the last one. Negative 2b to the third power is actually negative 8b cubed. So we are done with this and this. So the only missing term is the 2 middle terms. Let's try to compute for the coefficient of the 2 middle terms. The 2 middle terms is this one, 3 and 1 and 3 and 2. We should evaluate the coefficient 3 and 1 and the coefficient 3 and 2. So the coefficient of the second term, which is open quantity, closed quantity 3 and 1, is actually subscript 3 in front, capital letter C, subscript 1 on the last one. Okay? Meaning to say this is the coefficient of the second term. Because to bring out the second term, we just expand this one, but we must have to find the coefficient. And if we try to bring out 3 coefficient 1, it will be by using this one. Okay? It will be 3 factorial, okay, over r factorial. R is actually 1, and n minus 1 is actually 2 factorial. So this is 3 factorial over the product of 1 factorial times 2 factorial. Okay, the coefficient of the second term by using this formula here. And if we try to simplify 3 factorial, it will be 3 times 2 times 1. 1 factorial is just 1. 2 factorial is 2 times 1. And actually, these two here cancel with this. 3 times 1 is 1. 1 times 1 is 1. 3 over 1 is 3. So the coefficient of the second term, which is this, is actually 3. Right? It is this. Okay, the next coefficient, the coefficient 3 and 2. We must have to evaluate this one. The coefficient 3 and 2, it will be written 3, capital letter 3, subscript 2, meaning the second coefficient, this one. Okay? So, with this 3 and 2, by using this formula, it will be 3 factorial. Oh, R now will be 2, so this is 2 factorial. And 3 minus 2 is 1, so this is times 1 factorial by using that formula, this formula. And if we try to simplify, 3 factorial is 3 times 2 times 1, 2 factorial is 2 times 1, and 1 factorial is just 1. And again, these 2 here cancel with this. Okay? So the coefficient of the third term on the expansion is 3. So it's correct. The coefficient of the first term is 1. What we computed on the second one is 3. What we computed on the third term is 3. The last part is 1. Right? So if we now try to bring out the solution, this is the first term. This is the last term. I put it ahead. The second term will be 3 multiplied by the simplification of this, which is negative 32u square v. Why negative? 4 square is 16 times negative 2, that will be negative 32. So this should be negative 32u square v. But the coefficient is 3. We haven't multiplied yet. And the coefficient of the third term is actually 3 also, 3. And the expansion of this will be the product 4u times negative 2b squared. Negative 2 squared is 4 times 4, that will be 16. So this is 16 ub squared. But this is to be multiplied by 3 because this 3 here is this one. And if we try to simplify now, it will be 64u cubed minus 8b cubed. 3 times negative 32 will be negative 96u squared b. And the third term is actually 3 times 16, which is 48 ub squared. So this 96 u squared b is actually this one. Right? And 48 ub squared is this one. Right? Negative 8b cubed is this one. And 64u cubed is this one. Okay? So by presenting the factorial notation solution, it comes out that the final answer is the same as the answer by using the Pascal's triangle. I will repeat it for the last time. The final answer will be 64u cubed minus 8b cubed minus 96u squared b plus 48 ub squared. Okay? This one here is same as this. Hallelujah. Okay, that's it, guys. That's the solution of the expansion of a binomial expression by using Pascal's triangle as a first solution. We arrive at a certain answer, and by using factorial notation, and again, we arrive at the same answer, but we must have to evaluate the individual coefficient of this by using this equation here. That's why the solution is by using factorial notation, that is in the evaluation of the so-called binomial coefficient. We must have to compute this one and this one by using this formula here. Or that's the significance of this formula under factorial notation solution. Okay, good evening from Los Angeles. This is Professor David J. DelosReyes. The topic is expansion of a binomial theorem by using factorial notation. Hallelujah.